All right, today, whole episode is mostly going to be on the brand new Harley Davidson VVT cam setup on these bikes. What we're seeing, what we're working on, and how these things can really benefit you if you purchase one. So Mike's got more work on the VVT than me. He's been hands on it. Why don't you dive into how it's working, and then we'll dive into what that gives the customer later.
Well, it's pretty cool. It's actually pretty simple. You know, partly there's only one cam, so it is a oil-fed solenoid. I'm not going to get into too much technicalities, but basically the cam starts off full advanced, and then as you go through the RPMs and hit it harder, you can back off the cam, basically change where your lobes, where your intake and exhaust open and close, so you can adjust the power band for your level of vacuum or RPM range. So, you know, they've been doing it in cars for a long time. You know, it's how you get a Subaru Impreza WRX that has 270 horsepower, but you can still just put it around the parking lot and it's a 4-cylinder.
Right.
You know, and so it's going to be great because up till this point, a lot of performance is, do you want low-end torque or do you want high-end horsepower? Because,
or do you want to split the middle and do mid?
Yeah, you know, or do you want the best of both worlds? And now you can say, well, we can build this high-end horsepower that we can adjust to low-end torque, which is pretty awesome.
And riding the new CVO, so not all the new CVO touring models have them, but half of them have them. It just depends on which one you're getting. The new CVO ST does not have the VVT in it. It has Harley's Stage 2 cam in it already, right from the factory, but doesn't have their VVT. The VVT cam bikes are fun to ride. They're a little touchy at mile an hour. They're making good power at 70, 60 miles an hour, where when I was riding the bike, I noticed that I was liking to put on cruise control to hold a mile an hour because of how that cam operates. It's a torquey cam even at those higher speeds. And I wasn't sure how I was gonna like it, but after being on a CVO for 3 days straight, riding it across the country, it was awesome because it's got the torque in the corner. You come out of the corner, you're rolling into it, you have plenty of power, and then it has power at the top, and that's the Harley's factory cam.
Did you play with the ride modes at all, or did you just leave it in whatever mode it was in?
I played with the ride modes a little bit.
Did it make a difference on how aggressive it is? Because I know that with the computer that we're replacing Harleys with when we're tuning them, you know, we can go in and custom map the ride modes, and so we're putting like race mode, or well, it's got the little red
Track
S,
mode.
so I call it snap-on mode.
Sport mode.
It looks like the snap-on S to me.
It does look like the snap-on S.
I always call it, hey, put it in snap-on mode.
Randy, can you pull this up?
Yeah, the snap-on logo versus
Look at this thing.
the Harley Davidson track mode.
Real close to
Yeah,
the snap-on logo.
And
Check it out.
We saw that first with the live wires because they had the snap-on mode back in the day, and we were like, oh. But I haven't ridden a stock one. I've only ridden them after we put cams in them to test the modes, and there's a noticeable difference when we're doing the modes, because I mean that's why we're doing the modes.
The difference I noticed from your regular ride mode that the vehicle starts with every time you power it up was great. It was snappy and touchy, but when you go to the sport mode, it just rolls in faster and harder. You just have a little bit more. I mean, I wouldn't say it's mind-blowing, but you could definitely tell it's grabbing more torque sooner and making more power. Absolutely.
And I have no idea what the motor factory sets it at, but from snap-on to road mode, we go from 100% to 70% throttle. And then when we get to rain mode, we limit it at, I think Shane and I settled at 45% throttle.
For rain mode.
Yeah.
Yeah, so it's cool. Even when we're tuning these with the aftermarket ECM that we're using, we're able to give them 3 modes that they can pick, and they're still under the same exact icons that the factory Harley computer was recognizing them under. That's really cool.
Yeah, and cruise control works, all the functionalities there. But, and that one, what did that one do? I can't remember.
137 horsepower and 145
right.
pounds of torque.
It's crazy.
Yeah.
It's insane. I mean, that's a 135 motor from Harley.
Yeah, absolutely, with a cam swap. So if you have it's a 121 cubic inches, what we tested it on. And right now that was cam number 4. We have 2 more cams we're testing this week in the shop. And we're trying to hit over 140 horsepower while still making 140 plus foot-pounds of torque down the bottom.
We're trying to square the horsepower and torque on a stock build.
Yeah, if we can hit 145 with a cam swap on a VVT CVO, it'd be impressive. So we're working on it. We'll see how it goes.
Yeah.
We do a lot of stuff and we think it's easy, but for some shops, this is not going to be an easy, tunable setup for them. You got to understand how the system operates,
right.
And you have to have the products available to your shop as well.
Yeah, and I think you have to have, the program's pretty advanced, and it's not like, if you go from Power Vision to Direct Link to TTS, they're real similar in the way that they work. And they're all kind of like that, all the tuning devices. But this tuner was based in the automotive world, so a lot of the terminology is different. So if you don't understand what EGR is, if you don't know what exhaust gas regression or whatever, then if it's called something else, you're not going to know what it is at all. So if you kind of know what you should be looking at as far as what the fields look like, you can kind of be like, okay, this is my timing table, because I can tell by the numbers that these are timing numbers. So even if they call it trim, it's still cylinder timing. So if this is trim 1, trim 2, and we're actually working with the company to rename them our motorcycle names so that as time goes on, because it's going to be difficult, and people are buying them and they're trying to install them, and everybody thinks they watch a YouTube video and they can do it. Some people can, some people can't.
Yep. I think, this is mostly for the guys tuning the motorcycle that have to deal with the ECM we're talking about. But we already have shops that have a hard time tuning bikes where they run really well. We see it. That's probably the number one thing we see after someone does a build is just the tuning isn't even close to be dialed in all the way. It's probably 70% of the way there, sometimes 80, but there's stuff left on the table. Tuning takes time. It's not something you learn overnight, and you got to have a mentor really teaching you how to get there and someone to show you the ropes. And when you go into this VVT setup, you're not just tuning. The market's already having a problem tuning most bikes that are built. There's a couple shops that do it really well. There's some shops that do it, and there's some shops that are trying to do it. But I think when you add more aspects in of the cam actually retarding through the RPM range and us controlling it, now there's a lot more variables that a tuner is going to have to deal with and set up in the whole program for the tune. That's a little bit more complicated. So I don't think this is going to be at every Harley Davidson dealership. I think this is going to be a few and select shops that can handle the amount of work it takes to get it to run right.
And some of your higher end shops like V-Twin, those guys will be doing it. But yeah, I don't see this being a mainstream setup, because when you're moving the cam timing, you don't want the same cam timing at 4,000 RPMs at a 70% map load as you do at 6,000 RPMs at a 90% map load. So while you're actively changing the cam degree, you're doing it based on speed. So you're going to be moving it up and down. You're not just going from like wide open to wide open. One of the biggest rookie mistakes, I would call it, that I see when people do tuning with regular motorcycles is they go to their throttle blade and they just max everything out. They're like, you know what, we're just going to max, the throttle blade needs to open as fast as possible. Well, that's not true. The throttle blade needs to open as fast as you can supply steady vacuum to the cylinders to speed them up, which is not instant. And you can go back to carburetor technology. That's why they have accelerator pumps, because the accelerator pump is the bridge to going from idle to wide open throttle with the vacuum dying. Because as soon as you open the throttle, there's that moment where there's no air moving at all. So when there's no air moving, there's not pulling a bunch of fuel, even though your cylinders are now starting to gobble all that air up. The fuel's not coming in there, which kills the motor.
Well, and that's because RPM increases vacuum with the suction on it. So what you wanted to have the RPM, but the RPM, as soon as you do this, the motor didn't instantly rev all the way up.
It needs to.
So there's a lengthy period for the acceleration of the rest of the motor to catch up to that throttle.
So before you could do it electronically, you would have the throttle blade, which another misconception is your throttle blade increases your throttle, but it actually slows it down because the engine wants to spin until it explodes. That's the design of it. It's going to continue to go faster and faster and faster until it either maxes out the air and cannot move air any quicker, or it just blows itself apart because the mechanical components can no longer keep up with the speed of the revolution of itself. You know what I mean?
Right.
So the throttle blade is designed to slow the air down to keep the engine under control. So when the engine's idling, it's really about to die. So all you're doing with a closed throttle blade is going as slow as you can where the engine will still operate. And then you're trying to get it in its natural state, which is wide open. And then you're controlling everything from the beginning to the end. So on the carbureted, because there was no way to do that efficiently, they would put an accelerator pump so that when you had that quick snap of the vacuum where you have the pressure difference, where the engine's starting to speed up, but the vacuum hasn't increased to start pulling the venturi into the fuel, the accelerator pump would be a mechanical pump that when it opens, it pushes a bunch of gas in there. So the spark keeps sparking and sparking a ton of fuel so that as the engine's speeding up, it keeps running even if it's not real efficiently.
Yeah, because carburetor works off of air pulling across the carburetor to suck in fuel.
Right.
So when you're giving it more RPMs, the motor hasn't made, like we talked about earlier, the RPM to actually have the suction move quick enough. So the accelerator pump is pushing an additional amount of fluid in just to make up the difference.
Yeah, because otherwise it'll run out of fuel and die.
Yep.
So, you'll like on the old cars, hit the gas and it almost dies.
Well, we used to play with them where you had a small accelerator pump, a bigger one, and a bigger one, and they had different diaphragms in because some engines needed more squeeze of that fuel, and some needed a little bit less, fuel added in.
And you don't want to put too much fuel because then it just bogs down, and then it has to recover because you have all that unwashed, unspent fuel and combustion in there. So a rookie deal in tuning is they'll max out the throttle blade opening, and then the bottom end starts running, has a lean stumble, and they can't figure out what's going on. So they'll just throw a ton of fuel at it at like 1,800 RPMs. And you can see it when you pull them in, when they come in for a dyno tune, and they're like, oh yeah, so-and-so tuned it. And you look at it, you open up the tune that they had, and you're like, all right, so we're gonna back the throttle blade down, and we're gonna decrease the amount of fuel. And then what you get is your RPMs match your throttle. So when you whack the throttle, the RPMs rise instead of stopping and like burn, because that's usually what happens.
Like a stumble too.
It'll cause a stumble if it's too lean, or it'll bog if it's too rich. Like it'll just kind of flatline and then take off. That is a mismatch vacuum in the front and the back. That stuff is going to be really hard for not inexperienced tuners, because you're going to have to also at the same time change your timing while all that's going on. You're also actively moving the timing.
Well, not just the timing tables for the engine and the spark, but you're changing the timing of the cam, which is going to alter the spark table as well.
Yeah.
And your fuel table. So there's more tables to adjust for now and a lot more tuning. So now, if a shop was charging 4 to 6 hours, you might be paying 6 to 8 hours for these tunes because it takes a little longer, I would assume.
Yeah, because you're doing it 3 different modes. With each mode has a timing table and a fuel table and a throttle table, and then you also have your variable timing, your variable cam timing, so you're changing the mechanical timing as well.
Yeah, and looking at the whole setup, it's not that complicated actually looking at the mechanism. So what controls the VVT? We can buy that from Harley Davidson. We could plug it in a non-VVT bike, give it the new computer we're running, the ECM, tell the bike it's a VVT bike, and now we can convert any non-VVT center-cooled we'll be real precise, the new center-cooled ones, we can turn them into a VVT cam bike, because there is a lot of benefits. We haven't started to really mess around with larger cubic inch like 135s or maybe one of our 143s with a VVT cam, but so far on the 121, It's really cool because for an everyday rider that's using the vehicle for different things, using it to play around with his buddies, using it for the twisties, riding it in the rain, putting the wife on the back, loading the bike down, that VVT cam will do all of those very well.
Yeah.
And before, you either have a bike that's really hot on the street, but it's not going to like the rain. You have one that will put a cam in it for a lot of bottom and mid for if you're two up riding. And we can do that. And now with this VVT cam, you can kind of have something that performs very, very well all over the map of no matter what you're doing.
And we can adjust the ride modes to fit your needs. So, if you have you do a lot of cross-country touring and up and down hills with a lot of weight, but you still want to rip, we can adjust the road mode maybe to not advance or not retard the cam as much, so you don't get as much top end, and you get all the benefits of the low end torque, and you can still have throttle response.
Right, but we can still do the same ride modes on a non-VVT setup as well.
Yeah, we can adjust ride modes. We just don't have the third active cam timing.
Yeah, so we can still set up different modes for rain, for ride, and for sport. It's just the VVT we can control more because we can aggressively or slowly change the timing of the cam.
And one of the reasons that we stayed with Direct Link when they went to the torque-based tuning was the ride mode, because they were able to figure it out. I worked with them on the torque tables, and because I think, when you get these 150 horsepower engines, you're talking 165 foot-pounds of torque at 2,700 RPMs. They're dangerous when the roads are slick. They're scary to ride. I mean, we don't like riding them. We'll build these motorcycles, and if the ground's right, we're like, I'm not going to test ride it today.
Right.
Because what are we going to do? Just try not to crash?
Yep.
They just don't have enough meat on the road to connect because there's so much power, it just takes off, even when you're not trying to. So you either smoke your clutch or to not crash, or you just wait until the roads are dry.
It's not every motorcycle. I think it's our long stroke V twin motorcycles that make all the torque. We make a lot of torque really fast, like a diesel truck. If you try to drive a diesel truck in the rain, you barely touch the gas pedal and it lights up the rear end.
Yeah,
because there's so much immediate available torque. And I think these Harleys are torque monsters, and that's what throws the internet into a tizzy when a Harley makes 180 horsepower and we can beat a sport bike, and they're like, there's no way. It's like, well, there's a torque factor you're not thinking about here.
Yeah.
Same thing when we saw the King of the Baggers come out, and these guys are some of the best riders in the world. They're on their Indian or their Harley, and they're doing some test launching. You had a couple guys loop completely out on accident because the torque grabbed. They have a slick on the bike. It hooked so hard, it came up so abruptly and fast, they couldn't even get out of the throttle or got on the clutch quick enough to settle it down. We saw multiple riders loop out their bikes the first year of King of the Baggers.
Yeah, because they're not used to it.
They're not used to that.
They're used to nothing until 8,000 RPMs.
Yeah, it's a completely different thing. And they'll tell you that. They said these big machines, these big V-twins are nothing to joke about. So there's some sport bike guys out on the street that know. But we want to go over the VVT because as everything progresses, the stuff that's better will start to take over.
Yeah.
So right now we have two cams, and we're going to keep building bikes without the VVT. We'll build bikes with VVT. We'll keep experimenting on VVT cams in the stock setups. The CVO stock setup. We'll start to dabble in putting them in maybe some stock configurations with a 117 is the new standard motor on those bikes. So then we'll put some VVTs in 117, see how they do. And then we might develop some cams for maybe some of our big motors as well. So it's a more torquey cam, but when you want horsepower on it, you can have horsepower because we can retard the cam. We can retard it 20 degrees.
Yeah, we can go. We can. It's crazy because you can kind of design the cam for. We did it before. We designed it I want a big torque cam, or I want a big horsepower cam, I want something right in the middle. But these you can design. Once we kind of get it dialed in, we'll be able to design. I want maximum on both ends, or I want something in the middle on both ends. But we're going to be able to dial both sides of it in, which is pretty awesome. That's something that's never been done in the Harley world. Yeah,
the only thing that we've never really had to pay a lot of attention to when we design something is when we retard something, it's changing the valve to piston TDC clearance.
Yeah, the physical clearance.
We got to make sure we don't have too much lift and too much retardation in the cam where now we don't have valves getting out of the way.
I think Mark did. I think Mark found the limit. Have you
did
talked
he?
to him?
I haven't.
I think we were talking to Ben the other day because he came out with some more stuff on the computer, and I think Mark found the no-go zone.
Did he really take one that far?
I think so. Because when I was talking to Ben, I told him that, we went to 16 degrees, and then I said, well, we know 40 degrees we think is the limit, so let's go 5 more degrees and see what happens. It's either going to get way worse or it's going to start to pick back up again,
Right.
Like air-fuel ratio. It kind of stops, and then let's add a bunch more and see what happens. It's either going to get way worse or way better, and then take a bunch out. It'll either get way worse or way better. But it didn't do anything. It just kept getting worse and worse. So we're like, okay, we're going to go back to where our peak was. But he kept going and going and going and going. And I think he said it was 36 degrees.
Ooh, that's a lot.
Yeah. And then it went click.
Well, I don't think we're going to make it past 20 degrees before the cam drops off. Like you said, 16 is where it was already on the smaller cam we had. So we'll see what happens. But the cams we're bringing out, they're a little bit bigger, trying to make some more horsepower, are going to have to, they already have more duration in them. So you might not even have to go past that.
Yeah, I mean, it might even be less. We might end up with a big cam. It might only be like 7 degrees or 6 degrees.
Yep.
But that 6 degrees think about being able to take your intake opening from 50 degrees to 44 just with throttle.
Yep.
Or
start at 20 degrees and end at 40.
Yeah.
That's huge. And that's how we're able to get the smaller cam to create the middle horsepower and the upper horsepower, is because, and the cam's gonna be small. I think the valve train's actually gonna be happier too with it, because we don't have to do really steep ramps when you get into those real big lifts.
Yeah, and I'm not a fan of lift personally. I like getting the power through compression more than lift because, man, it's just a lot. It's a long ways. When you do it 4,000 times every minute, that's a long ways.
Well, lately too, we've seen a lot of stuff come through the shop with lifter failures. Mm-hmm. And there's some not every lifter is created equal. We can tell you that. Some lifters they just don't hold up as good as other ones. So if you are building a high performance motor, you're doing big lifts, you might want to swap your lifters 10,000, 15,000, 20, depending on the motor setup you have, because it would cost you roughly $600-700 to put all the best quality lifters you could put in, which we like the Fueling Race lifters because they're made by Johnson, the best ones we've seen. And you can get those lifters installed by a shop for $700, or if you wait and don't do it, it could take out your whole engine.
Yeah, or you could see if you can sell the frame on eBay, buy a new bike. So can we talk about the 135 project? Because that one we're going to do a lot of experimenting on, or is that still kind of like...
Yeah, we can.
Because I know most of that will be on our YouTube channel.
Yeah, so we're going to take a Harley Screaming Eagle CVO ST, and Harley's giving us a 135 engine for it. And what we want to do is we want to show different steps of what you can do this. We're going to start with the bike stock with the motor. It comes with the 121. We're going to put in the 135, show what the 135 does under Harley's warranty with everything the way they sell it to keep it warranty compliant. Then we're going to add some cool parts. We're going to start small. We'll probably start with the exhaust or two.
Yeah.
And then we'll tune them. And then we'll add some cams to it and tune it. And we might have an option that make it a VVT.
Yeah, I think that's the one that we want to experiment to turn a non-VVT into a VVT, right?
Yeah, that'd be
because
perfect.
I don't see why we can't do it. Because the only reason that the 117s are not a VVT is because they don't have the solenoid or the driver.
Yeah.
Which are bolt-on parts.
Yeah, once we get those, if we can get those parts from Harley and get them installed and everything works correct, we're on. And then we can, I think that thing with that cam we're already testing, I think it's going to be a monster. The VVT cam in it.
Yeah, and I think it'll work because we can put it wherever we want it.
Yeah, and I think we'll sell more of these setups, maybe with the Harley crate engine, because the cost of them's a really good price point for customers.
For what you're getting.
That much cubic inch. Absolutely. Comes with all Harley's best parts on it. So we grab that guy, we just swap it out to a VVT cam. That way you can have power everywhere along the curb. And I think for your average rider that wants performance, that's not just a racer, is going to love that setup.
Yeah, and you'll have all the different modes, all the bells and whistles. I wonder, I think we talked about this before. The ST has a stouter gear ratio, and I don't know why they did it just on that bike, just this year. Personally, I think it's the gear ratio they should have been running the entire time with a 6-speed, because 6-speeds are pointless to me.
They were actually building and designing the CVO ST Road Glide before they actually even started racing King of the Baggers. So I think when they were doing that and they wanted to do the performance thing, the first thing they did was come up with options for different ratios, because they know they want it quicker out of the hole. They want the bike real snappy. And I think they just started testing it. And something we talked about before we went live today is, hey, when a manufacturer grabs something, it takes them 3 years from concept to delivery to the customer. And when you want to do something like that, these companies aren't like, oh, this is available over here, and here, we'll just throw it on this bike, it'll work. They test it, because if they make a mistake, it's so costly to do a recall campaign that they don't want to mess something up.
Yeah.
So they spend the first year is getting it designed, getting everything on the bike, testing the bike, getting it approved, running it through the ringer. And then, the first 2 years they do all that. And then the last year is they order the parts, they get the production plan ready before that model year is going to start, and they have to have everything come for that model and be ready to go so they can build them at the facilities. So it's a little bit of logistics there. Once you say, okay, cool, everything works together, now it's a logistic thing just to get the companies to produce everything you need and to get everything ready for the next model year launch.
That could probably be its own episode.
Yeah.
Just talking about how you get from A to C in the manufacturing world, and what the dealerships role in it, because, we all play a part.
Maybe one of the guys from Harley Corporate come down, let us know what they deal with. Be interesting.
That'd be cool. I think that's probably about it, yeah?
I guess more VVT later.